Hello workers, welcome again to physics. This is number 4 of Van Allen belts, which we briefly mentioned before. Hopefully this should be short and sweet and I won't talk too much for you. They're also called, well, the Earth is surrounded by a number of radiation belts, or these are areas of more concentrated radiation, and they include what's called the Van Allen belt, or sometimes Van Allen belts, depending on who you're talking to. And so what's the basics of it? Well, we've got this magnetic field around the Earth. We should have a pretty good picture of it now. It's distorted because of the solar wind, which we're going to learn about in the next video. So it has a tail pointing away from the sun, exactly like the tail for, well, not exactly, but looks like the tail for comets that they have, and that can extend, and even the moon goes through this sometimes, and people were interested in what happens to the moon when it goes through it. So what's happening is that the Earth's magnetic field, these charged particles are coming from the sun. They interact with the Earth's magnetic field because charged particles, when they have a velocity in a magnetic field, they experience a force, and that force causes them to spiral in, and it sort of becomes like a magnetic prison for them. They get trapped, and they spiral in, and they get trapped in certain zones in the Earth's magnetic field, and so there are these donut-shaped clouds in space that have slightly higher concentrations of these charged particles. So we probably learnt that space is a vacuum and it's pretty empty. Well, these belts, the radiation belts and the Van Allen belts, are not as empty as the rest of space. They have more charged particles in them, and they basically sit above the Earth's equator by a couple thousand miles. And okay, and they're named the Van Allen belts because they're named after Dr. James Van Allen, who used one of the very first satellites launched by NASA to look at the variation in radioactivity, or radiation, to be more precise, as it orbited around the Earth. And that's what he looked like. There you go. He got his picture on Time, which was a very prestigious thing in those days. And this was his diagram where we have Earth, and he saw these radiation belts where there's concentrations of radiation. And the Earth has two belts of slightly different origins because there are different mechanisms that cause them. One is predominantly protons, and the other one is predominantly electrons. Different charges, different masses, different effects. The inner belt was one mainly discovered by the Geiger counter of Van Allen's satellite, and it's a byproduct of the cosmic radiation. It's populated by protons with energies from 10 to 100 mega electron volts, which we should understand that it's fairly energetic, but not as energetic as it could be. They're energetic enough to penetrate spacecraft, and with prolonged exposure could damage instruments, albeit a hazard to astronauts. And so most spacecraft tend to stay out of this region. They whiz through it if they have to, but you wouldn't be sitting in there for too long because it's not healthy for you. And this is a diagram that's trying to represent that. So we've got the blue and the purple are the two different belts, the inner and the outer. The outer is the electrons, less harmful, we could say. The inner is the protons, more harmful. And then inside that, people are now recognizing that there's a concentration of dust, because dust can be charged and it gets concentrated and it interacts with the protons, and so relative to the rest of space it's a little bit more dirty. And there's just a diagram showing the donut shape of them, and this one's just showing how here's the solar wind coming along here, the charged particles move along through space, and once they hit the Earth's magnetic field they go into these spiral loops and they get caught, basically. And we'll look at that in more detail when we do the solar wind, which is our next video. That was pretty quick. Hey, see you later.